All right, so today we're going to look at this. We talked about this. Let's look at learning objectives. So yes, I kind of separated them with respect to map, string, date, and math. There's actually a lot more objects in JavaScript. Yeah, for some reason, I think we get to review these. I would pay attention to string and maps. These are the most fundamental. One of them is the data type, and the other one is a data structure. Okay, like map is data structure. So these things are important. And math is a library, so is date. But you could make use of math to compute, do mathematical computations. You can make use of date to get the date and time, even the number of milliseconds. A lot of times you use date to compute, watermarks or the day of expirations or something like that. When you have to compare two objects, they'll have sort of a different set of freshness in terms of when they were created. So use date object for that, like comparable date analysis. You use string for pretty obvious reason. You do string manipulations. This is how you're able to create literally a list of characters, right? Sometimes you use these to represent value. Sometimes you use these just to print them out onto the screen. So there's a lot of string manipulations that will be done using string. Map is a data structure that is very useful for key value pairs. A data structure is a abstract concept for storing data, allowing developers to manipulate them, right? Manipulating data calls for updating them, deleting them, modifying them, or you can add to it. Okay, so these are the type of data wrangling or data manipulations that you would do. And you simply use map or data structure to store these informations. And sometimes these data structure have specific properties associated with them, right? And this is where we get into abstract data types. Again, I think some of you probably went through my data structure class and know what I'm talking about, but if not, don't worry about it. So we're going to quickly go through these today. Plus, we're going to review what's called exception handling. This is error handling that is very useful in doing JavaScript, especially with respect to running data in them. Sometimes you get into errors, even when you connect, to maybe client-server connections. You get these errors. You have to catch them. So this concept is not new in JavaScript. It's been around since C++. So we're going to go through that quickly today. And then we're going to spend the remaining set of the class. I'll see how much time we have. Hopefully we can get to this. Okay. But if not, my goal is to get to this. Okay. Today. And if some of you from my HTML, CSS class prior to this class already have maybe some of these already. We'll see. Or maybe even this. So it depends on where the class is at. But these are the Bloom's taxonomy verbs that you would need to, that calls for different levels of understanding and interactivities. Most of them is to learn, is to understand, to explore. When you see something about implementation, this is hands-on stuff, okay? I really do want you to write code to handle this. And you'll have that type of opportunities in usually challenge activities, okay? But it doesn't hurt to maybe spin up an IDE in JavaScript. There's also online IDEs where you can try to to code these things. Any questions so far? All right. So I want you to take away from this class thing. This is not just a survey class that talks about every single nitty-gritties of JavaScript and there's no hands-on. You just listen to a professor and that's it. I want this to be a little more hands-on than what is available, right, with Zybook. Zybooks, I have no control over. I mean, the curriculum is already made, but yeah, we'll see at the end if we have more time. I'll get into more hands-on stuff. As those of you who took my JavaScript class before, and it was a bit more hands-on than this Zybook version. All right, any questions so far? All right, let's quickly look at reading topics. These are I got rid of the links into Zybooks, okay? Because apparently if you just click on these links into Zybook, you cannot do homework and expect those scores you obtain to be uploaded. So that's why I got rid of this link, but you know where to find them. Okay, it's 6.10, 11, whatever. If we go to Zybook, you log in first. All right, and then you picked the book. Actually, you probably only have one book. I don't know if you have other classes. 6.10, so on and so forth. So this is what we're going to complete, hopefully during the first half of our session today, and then we'll take a 5 minutes break, come back, and then finish the rest. There shouldn't be much for the second session part of today. All right, good deal. Let's go back. There is a small reference. So this is the reference I use in my React class. This is occurring so often, and in fact, when we go through, I believe, maps, you'll see it. Okay, so this is one example. All right, any questions before we start the lectures? All right, let's quickly go over maps. So map is just like object. Map is a hybrid of I would say object and array in a sense in JavaScript, because what you have is a key value pair, but then again you can also use curly braces to encapsulate them, right? You can see the curly right here, the opening and closing, and sitting in between you see key, right? And then colon value, key, right? Key 1 value 1, key 2 value 2, right? Kind of like this, right? The interesting thing is the key itself doesn't have to be a string, and on the other hand, these values, as the this thing illustrates, is a string, but technically value could be a number. Okay, it could be a lot of things. Value can also be another array. Value could be another object. So there's a lot of things you can do with this type of setup and syntax. But map itself is well, at least in the sense of this JavaScript map, is an associative array. Associative array is it's an array. Okay, it's an array. Array looks like this. Okay, and you can specify the key. The key itself usually is a string or some sort of object that you set up. And in the traditional array, your key is what? Is your index, right? 0, 1, 2, 3. So like I equals 0. So I will be your key, and your value will be sitting in here, right? V2, V3, V. Does it make sense? So this is like the traditional linear random sequential array, right? But this type of array, which is called map, uses a key that is not really a number, right? It's something that you would specify like these, okay? And then the value will be sitting inside of this, v1, v2, v3, v4, okay? So these v's could be string, could be number, could be, array objects. So you can have literally an object in there. It doesn't matter. So this is the reason why we use JSON to represent this a lot, because in JSON you can literally create this in a text file, and this information in JSON could be parsed or serialized into a JavaScript object at runtime. So that consumption happens at runtime. The storage of that serialized object from JSON into a JavaScript object is also done at runtime, just in time, super fast. This is the reason why people prefer to use JSON as an object to communicate data in JavaScript, okay, or JavaScript-based applications. So let's quickly clear this. Yeah, what I like to do is let's go through this animation so you can kind of see what's going on, okay? So we have 3 frames here. The very first one is this entire map. So if you were to expand this entire map into this, the map has a name called state capitals, and this state capital is a reference to this map object. This map object literally has three, it's basically 3 elements inside the array. The only difference between this map and regular array is that instead of using an integer index, right, you now have AR, CO, and M. Okay, as the key. This is the key. And this will be the value sitting inside of it. All right, let's move on to the second frame. The second frame is doing this. It says CO capital. This allows you to, so this gives an example of how you can retrieve your data, right, from this. So the way you do it is to write this. Make sense? So CO is literally transformed into a string. Even though it doesn't look like this is a string, right? There is no double colons here. Not double colons, sorry, double quote. But you would treat it as this is a string. So the way that you do it, this. So that's what's called associative array, right? You can use key to fetch a value. That's basically what this associative. Everything is associated. Each value or each key is associated with a value, right? Not the other way around, because sometimes you can have several values that are the same value, right? But they have different keys associated with them. Okay, so keys are unique, right? If key collides with each other, that's pretty bad. In that case, you will not have a map. In that case, your JavaScript will probably bark and give you errors. Okay, any questions so far? Yep. This is the very last one.
Oh, sorry. Is an array similar to a dictionary in JavaScript? Or not JavaScript, Python, sorry.
Python, yep. Python dictionary is associative array, yes. So the very last example, which is 3, let's do this again, allows you to assign a value into this map. So the very last statement right here. Sorry, I have to toggle different keys. This is what we call assignment. Okay, you're assigning this value into it. So what you're doing is you're write. This is the write operation. ION. Yeah, the very last one is the write operations. All right, any questions? So this is a very rough, high-level overview of your map. Okay, and I think these are pretty easy stuff. Object maps. You have simple tries. You can do this. But please make sure you it's okay to make an error, right? But you want to correct it, right? So that way you can get full points. So I believe there's a point associated with each problems here. And even you don't get it right, I believe you get credited if this thing lights up. Right? Usually this turns into orange, I think. So that means that you've done it. Okay. So you get all of the participation points associated with this particular PA by completing all of them, making sure there's like orange bar next to it. Okay, this orange color thing. All right, so the next one up, it's a very interesting. This is a loop, a special type of loops called for in loop, and you probably maybe have seen it from in other contexts. And the syntax looks very similar to a regular for loop in that there's a for keywords right there. Okay, but what's kind of different is what's inside of this. This is a very shorthand way of writing something like integer I equals. There's no such thing as integer in JavaScript, right? But I'm talking about like in C++ and Java, integer I equals 0, and then I less than whatever the size, right? And then do I plus plus. But instead of writing something like this explicitly, you would literally just treat this entire object like a collection of things, and you want to get every single collection or elements inside that collection by using in, right? By using a for and an in. So this is a pair that you have to remember. And we use let, but typically this let could be a var. It doesn't matter in this context whether this is a local or global variable, but this entire variable is extracted out of the object. That's one thing, right? The property number 2 is that by doing this, there is really no ordering, meaning you don't just sequentially go through, I equals 0, let's fetch the value. I equals 1, let's fetch that value, right? So on and so forth. There's no such ordering. This order is dictated by whatever comes first in memory inside this object, okay? So you're able to go through every single one of them, writing a for in at the same time. You don't have to worry about the ordering, okay? Who cares? We don't care whether this Little Rock is before Denver or Santa Fe before, right? But you can apply this entire for in the context of map, okay? So this entire object, by the way, map is the type of object. So I think I mentioned this, right? Everything's an object in JavaScript, including even the data structure itself, right? So I don't want you to think this entire map is a map. It's different than an object, right? In fact, if you just go up and remember what I just did, you can see the syntax of your map, right? It's using this curly, right? So what is a curly? This curly is an object, right? Object, okay? JavaScript object. All right, so you can think of this map as a specialized version of the object, period. All right? As such, an object needs to be instantiated. If they're primitive, fine. You don't have to instantiate it. Instantiate means dynamically giving it a memory address and store the value of that instance at runtime inside a memory space. So that actually takes up some of the heap memory space if you do that. Anyway, questions? Yeah, I'll come back to for in. I wanted to give you. So yeah, I'm not gonna go through this, all right? Otherwise, it'll take forever. But yeah, let's look at some of the object map operations. So these operations are what we call methods. So that you have a object called map, okay? And this map is the same as an object. Okay, it's a specialized version of object. We talked about this. This object at runtime has methods, okay? And these methods are kind of like defined function that can do a lot of things. So like getting number of elements uses dot keys. And these objects are references. So in Java, in JavaScript, when you are accessing a reference objects method, use dot operator, okay? D-O-T operator. So this is the reason why you see dot right here. So object dot. So this object is instantiated, okay? Instantiated meaning created, okay? Created object. Or sometimes we call them instance, okay? Instance of a class. So in the context of your object key here, let's see what happens. Check for the key in operator, so undelete. Yeah, so I think there is an example of this. Let's take a look. So your entire state capital is an object, is an instance of this map. So as such, at runtime, you can dot something into it. And this entire object is literally a library. Okay, this library provides this function. This method called keys. This allows you to pull all of the keys out of this map. So remember, map is key 1, V1, right? K2, V2, K3, V3. K stands for key, V stands for value, right? And then there's this giant curly braces surrounding it. So this is a map. So when you do objects.key, you're invoking this library, this object library's keys method to extract all of the keys out and store them in this object's memory. So that way you can store, right? You're doing the assignment, right? So what comes out of this dot keys is this guy right here, right? This entire thing inside an array. So you're flatten this key 1, K2, K3 into a linear array like this, okay? So K1, K2, K3, and what do? You assign this anonymous array as a value into this thing called state. So this state is a reference variable pointing to this array of 3 keys. That's what happens right here, okay? So there's a load of stuff that happens in this line of code. And then you can print it out using console.log. You can also use if, in, right? This in thing is very important. All right, any questions so far? Okay, let me see the time. I think we're doing just okay. Yeah, these are all activities that you're gonna have to go through, right? So you don't have to memorize this, but just remember every object, every library, every data structures that you see in JavaScript, there is a set of methods that comes with it. So map is pretty famous data structure that has a whole bunch of what we call transformer methods, and these are observers methods. Okay, so transformers and observers. Transformers means that it's a whole bunch of read and write operations. Observer is a whole bunch of read only. Okay, like, oh, by the way, delete is transformer, get is transformer, set is transform. Actually, get is considered observer because this is only read, and the transformer is more about write. Okay, so set is a write operation, has is an observer, get is an observer, delete is a write operation, size is an observer. So each object has or at least a data structure, in a data structure sense, has a whole bunch of transformers and observers. So map has these methods that allows you to set a value based on the key, allows you to get the value based on the key, checking to see if the key exists using has. So in some contexts, they probably have a method called contains or has, or has value, right? It depends on which libraries and programming language. They may have different naming conventions for these things. Okay, so if we're to look at this particular animation, I think we can get some insight into what's going on. Let's start off with this. The first frame is instantiating a copy of your map, right? So I mentioned this before. Instantiation calls for new. This calls for the allocation of your heap mem, okay? Allocation. So if you look at the whole memory cloud, this is the heap memory. Heap memory is where memory could be dynamically allocated. Dynamic meaning at runtime. And this whole bunch of memory, and these are consecutive memory, okay? They're sitting next to each other. It's allocated to this map. And this map has a reference name called state capital, okay? State capital. That's what happens. This entire place, like this thing in red, it's all this guy right here, okay? So inside this guy, you can then set the value of each key accordingly, okay? So you can say, hey, I'm gonna set up the 3 of these, right? Slots. The very first one is AR. The second one is CO, Colorado. The third one is NM. Okay, and then you have the values in there. One of them is Little Rock, the second one is Denver. The third one is New Mexico, Santa Fe. So these are the value, right, sitting inside of it. That's what happens here. So if you look at the second frame, all right, this is where that whole map, right, is created. Initially, you have an empty map, and then later on, you get values inserted in there, like key value, key value, key value. Right? You do this sequentially. And the third frame shows that you're printing the map size. And this map size could be invoked using a dot operator by dot its size. And that's going to give you 3y. Well, the size of a map, right, is how many key value pairs you have, okay? So if you look at key value pairs, there's key this value. That's considered one pair, right? So the definition of size on a map is how many pairs of key values, right? In this case, it's 3. AR to Little Rock, CO to Denver, right? New Mexico to Santa Fe. All right, so let's look at the next frame. So next one is it's checking to see, hey, state capital has this or not, right? If it does, then it's going to print this. And printing it also involves getting the value of CO, which is Denver, and then you see this printed, okay? Very next one shows the whole block at the end. It says all capital, so you're gonna have all capital console log plus this key value pairs. State is capital. All right, so this key value pair is this. All right, now this is a little different than what you've seen before, but what is this? This is an array, right? Array uses bracket notation. Okay, and the reason why you have this and you can do this is what's called destructuring. Okay, yeah, I am a little disappointed that they don't talk about destructuring here, but yes, this is a fact called destructuring in JavaScript, and I don't think this is gonna be on your quiz, seeing that I don't see it here, but there's actually a lot of stuff going on here. Okay, but yeah, I don't want you to take everything for granted. You have to investigate and try to be critical of what you learn in this class, and don't just take this for granted, because sometimes you can miss a very important concept. If I don't tell you this is destructuring, you probably never know, and it will take you a long time to get to it. Anyway, so that's kind of yeah, now I think the completion of map, but I want you to pay attention to this thing called for of and for in. I did manage to create a quick video for it, and this is a difference between, so in a prior I believe there is a for of, right, at the end. Let me see, I think I saw it. Yeah, there's a for, you see that, and there's of, right? And then all the way at the end, in the beginning, you have for in, right? That we talked about this. So what's the difference between the two? This video talks about that. So let's take a look.
This for of loop is a new syntax in ES6 that simplifies your code. This for of loop works for any JavaScript iterables, which are collections of elements that you can iterate on. You can think of these iterables as arrays, strings, lists, so on and so forth. So for example, if you have an array of characters, you use for constant elements of array, you are able to get back the elements, which are A, B, and C back, respectively. Before ES6, you could have gotten those elements as well by writing a for loop. Have an element in array 1 that way to get your iterations going, but then you have to console log your array 1 with the index ELE. This is very cumbersome. With the advent of for of in loops, you can simply just get your elements out by specifying this off, OAuth, to get your elements out. Here's another example where you can iterate over a string, which is a collection of characters. Using const value of iterable, we can then fetch the value directly outside of it without using any random sequential indexing. Same thing with map, which is a collection of key value pairs, as illustrated here. In the very first example, you can get back the key value pairs one at a time through use of entry of iterable. In the second example, we have what's called a destructuring. So you can apply destructuring to the for of and fetch individual keys and values in each pair directly. Same thing with set, which is a collection of elements that do not duplicate. You can iterate the value sitting inside of each set, but notice that set gives you unique elements. So even though there are 6 elements inside, the only unique elements inside this collection will be 1, 2, and 3. So your actual set only contains 1, 2, 3. This is the reason why when you do a for of, you're getting back 1, 2, and 3 in that order. And notice that set does not have to be sorted. Why is this important in web development? Well, in web development, sometimes you have to deal with DOM objects. When you try to query a selector and select all of them, you get back a collection of them or an array of them. Instead of writing this in the for in way, we use for of to fetch every single element that matches this articles P one at a time. And you do that in React as well. This simplifies code a lot. For in, on the other hand, iterates over all enumerable properties. So when you do a for in, you're iterating all of the properties of an object. That object could be a key value pair. The enumerable properties will be A, B, and C. And when you want to get the value associated with each property, you would do that collection name, bracket, that property name. This is how you get your desired result. So that's for in. For of, on the other hand, instead of iterating over the enumerable properties of an object, it iterates over the properties that the iterable object defines to be iterated over, meaning the value that is associated with what's inside that object, which in this case is 3, 5, and 7. So this is the reason why when you do for of on this iterable that contains 3, 5, 7, you get back 3, 5, 7 instead. Doing a for in, on the other hand, gets back a enumerated properties. In this case, would be the indexing of each of these elements, 0, 1, 2, plus foo, because this iterable object also has a property called foo, where the first 3 represent the array properties, and the very last one is the object property that you just created here. So yeah, you're not going to see the last 2 here. You will simply see 0, 1, 2, and foo printed in your logs. And these are not integer. When you print it, the console shows the values like 0 instead of double quote 0. This completes the discussions of for of in ES6.
All right, folks, any questions about this?
Yeah, it seems like you can use the word const instead of let, right? Because
Yep.
in the okay,
Yep.
thank you.
Yeah, so const means read only. You cannot write, you cannot modify key. If you use var and let, regardless whether global or local, you can change the value of key, which is pretty bad. But why would you change it when you're in iterations? So a lot of times people just use const. Okay. The difference between const and others is one is read only and the rest of them are read and write. There is a demo link that I included here. So by that I meant you can actually go into the reference and click on this. This is a link to this. And this is a playground that I set up to demo this, but really don't have the time to demo it. You can see the JavaScript here. You don't have to put any HTML, CSS. You can literally just play around with this and compile. I believe, hold on a second, let me see. Yeah, I don't think you need to sign up or log in. You should be able to play around with this. Let me see. I think they probably changed.
You can hit like the backspace on one of the brackets to get an error and then add it back on and it'll compile, I think.
Yeah, the thing is there used to be a button here. Yeah, this thing.
Yeah, I don't see the results field in the
Right
bottom.
there.
Oh,
It's
there
right
you go.
there. Yeah, this is so this white thing is the HTML, and there's really no HTML here, so you can actually mask it and just go to the console. Okay. Yeah, and then anytime you change something, it should automatically trigger the just-in-time JavaScript, and you can have it loaded. So this is how you would play with this using CodePen. And yeah, this is my playground with my specific IDs here. You can play around with this, okay? This thing it's not gonna it's not gonna change anything I have in the system, but yeah. All right, questions? Any questions? All right, so I think we're done with just one topic. We have several of them. All right, let's look at string. So this string is also an object, and some of you probably had a lot of experiences with string in other languages. So string is a collection of characters, charts, and chart is character, short for characters. And you will see a lot of very familiar method names and even the functionalities as a string is associated. That string associated in a different language. In fact, chart at, it's the same as what you see in C++ and Java, length as well. So if you do test as an instance of your string object, dot chart at, meaning you would invoke on this particular methods by passing in this one, which is the index value, as a argument, then this is going to give you the character at index location 1, which is the second one, because the very first one has the index location of 0, right? The second one is E, so this will give you E, index 1. All right, so on and so forth. Let's quickly look at this participation activities. So, oh, where is I love JS? That's my name. Total space is 0. So this is simply just a declaration. Okay, you are declaring this S and defining it to have this value. By the way, I was joking. JS is not my name. It is short for it's my initials. Yes, but J stands for JavaScript. I'm pretty sure that's what the author means in this context. All right, and then we declare a total space equals 0. Fine. And then we start with our index, sequential indexing loop that says I equals 0, I is less than s dot length. So what is s? S is I love JS dot length. That's the total number of characters basically. So there's 9 characters here, including space. All right. So the drill goes s dot chart at. So this is trying to iterate every single element inside this array and see if that chart at index I is equal to a space. So the very first space that's going to be iterated on is through is going to be the index number 1 and index number 6, right? Both of these carries a space. You would count the number of spaces by plussing itself, and iteration continues to go on. Okay, I plus plus. What? Sorry, I plus plus. Yep, that's done. And this is gonna keep going until I becomes 6 and your total space is 2. Same logic. And after 9 iterations, you're done. And you print out the total spaces equals 2. Make sense? So there's a lot of stuff going on in this, but you're familiar with the control structures in some languages, even Python too. This should be pretty straightforward. Any questions? All right, so that is a very basic fundamental stuff associated with string. There's actually a lot more operation you can do by calling for a substring. Substring meaning a portion of the string. So you can do a lot of stuff. You can do searches in a string to see if there's a particular characters, using index of to find the location of that characters you're looking for. You can also do a last index of, as in the very last elements index inside the collection of characters. You can also do a replace. So it's almost like search and replace, right? You can do a try to see if this character exists or not, find out its index, and then you can replace the value at that index. Make sense? So this is almost like you can think of this entire string as an associative array, but it's really an integer array because you're using indexing, which is itself an integer from 0 all the way through array.length -1, right? So this is kind of a numeric associative array, and yeah, you can do a search and replace. So I believe there might be a quick, yeah, I don't think there's any animations. Any questions about this? Just look at the examples, okay? start with this. Yeah, I believe this is pretty straightforward. You can do a search or replace in the fashions like this. So what you do is you call its dot replace. This dot replace replaces one string with another and returns a string with a replacement string inside. You can say, seek and you will find. What you want to do is you want to replace find with discover. Okay. So the very first one is the characters at hand. This inside this S. The second one is the one that you would want to replace it with. Okay. So if you find this find word, you will replace that word with discover. So your string is going to look something like this. Yep. Okay. So even though this is already part of your string object, this entire replace has an internal for loop that also invokes this index of in order for you to do replacements like this. See, if you look at this carefully, you'll see there's indices, right, associated with each of these characters. And this F could be index 20, right? Let's just say index 20. So in order to replace this entire find, you need to start with index 20, right? And that is where index of comes into place to get you that index of that F right there. And this is where you just basically overwrite that F with what you have as the very first character of this discover. That character D occupy index 0. So in order for this entire replace to take place and deliver the results you need, there is for loop, there is find, there is the index of, there's also this reassignment of characters at the starting point that you know of, and concatenation of the characters after that, with a new one. So there's a lot of mechanisms at play inside this replace method. Okay, so you guys are just getting this for granted because once you have this entire string, you can just invoke its replace. But the actual implementation of each of these methods is pretty involved. All right. So you can look at some of the other string methods. So these are very, very commonly used. You see this a lot, like substr, substring, split to lowercase, and trim. So substring, sub str returns the substring that begins giving this has an optional given length. You can see the examples here. The difference between this and this is this one takes 2 indices. Sometimes you don't have to specify the second index. If not, the second index, it will just literally give you everything from the third location onward all the way to the end. Okay, or you can specify the string in between. It's totally up to you. So they're kind of synonymous with each other, these two. And then you have split. Split is more about separating an entire string into chunks. Okay, to lowercase, uppercase, I think this is very self-explanatory. Changing everything to lowercase, changing it to uppercase. Trim means getting rid of spaces. Okay, so if you have something like this, after you trim this entire test, it gives you the sanitized version of only characters, no white spaces. All right. I find going through these API documentation pretty tedious because I already know what they are, but you don't know what they are, but they all read kind of the same, It's like studying a foreign language. I don't want you to memorize this, okay? Please don't. But yeah, make use of what you just learned in these participation activity at home, okay? All right, there's a lot of stuff. This will take you probably a good half an hour, 45 minutes to really get it, and maybe another hour, 2 hours, because there's code that you're gonna have to write in order to pass this lab, this PA. Okay, and I think I mentioned something about literals. Literal means constant. So when you have a template literal, we see this a lot. This means that they're templatized, and there's a constant associated with it. That's how you would interpret these things. So whenever you have something, and this is the backtick. This backtick is if you look at the escape characters on the top left-hand corner of your keyboard, right beneath that ESC button, you'll see that uptick there, right? Along with the tilde in the same button. That is a backtick. This allows embedding expression with a $sign in braces. So this means that this entire expression is literally a wildcard to be filled by this dynamic variable with a literal, with a constant associated with it. So this would say something like test 3, okay? Because it would evaluate this, and whatever the end result is going to be a part of this entire newly created string called test 3. All right, so the reason why you have template literal is to enable some sort of dynamicness, because some of the values you don't know until you are at runtime, you're running the program. So doing this can dynamically gives you a string with values that gets evaluated only at runtime, right? When you write code, you didn't know what that expression is going to be. You know what it will look like, but you want to use this dynamic runtime substitution, right? Literally, this is what template literal means, okay? Let me see. Yeah, I guess we can quickly run this. Number one is, see, we'll do this. Yeah, this is a concatenation. And then you'll print out the results. Yeah, the second batch right here is where the templatized literal is. You can see the dynamic insertion, right? This X is evaluated already from the previous, statement. And then the third one is to conclude everything. Okay. All right. Any questions about this? All right. Like I said, there's string object reading assignment. There's also what's called template literal. So this template literals shows up a lot in industries. Okay. So we do this all the time. Make sure you read up on this. There's a lot of pages here. Try to get as far as you can, but do not get overwhelmed by these other use cases because they can get pretty involved. Yeah, I don't want you to get bogged down into the details. Okay, focus on the high level, given that this is a survey class. Okay. Survey in the context of this class means high level overview, giving you the breadth of the knowledge in this domain. All right, so this is, why don't we just like quickly go through this in a couple minutes, because yeah, we need to give you a break. So date object, like I said, is for encapsulating anything about time. And inside this date has the capability of giving you this Unix. I call it epoch, but I think this is epoch. It depends on which teacher you have. This is literally the number of milliseconds transpire ever since January 1st, 1970 UTC time, Coordinated Universal Time. This is also the same as GMT. So UTC 0. So this date object is going to have a couple of methods. So we'll talk about those. But before that, let's look at the constructors. So the very first thing you do is dynamically instantiating using this new operator, a date object called current date time. Okay. The second thing is to print it out, this current date time. That's going to give you this. So if you don't specify any specific format, it'll give you this long string of pretty user-friendly, in my opinion, information about the date. Then you're going to get into setting a new date. This is called 1 second past epoch or epoch. And you try to print it out. And this is going to give you this. Let me think. Right. So this number 3 means is initialize variable 1 second past epoch to 1,000 milliseconds past that. So 1,000 millisecond translates to a certain amount of hours and minutes after January 1. So that's what this really means. You can create a date object after a certain time past the initial, epic. So that's what number 4 is doing. Number 5. I'm sorry, number 4 is printed out. Number 5 is the creating a new date with a specific date you have in mind. Okay, so this involves February 2nd, 1732. Number 6 is to print it, and then you can see the end result. So I guess this lab focuses on how you can instantiate, make use of various different constructors to create a data object, and this data object will be set up accordingly as you configured. Yeah, there's a couple of date method, and these are getters and setters about getting the millisecond, hours, year, right? So we do this a lot when we're dealing with the calendars, and sometimes we have to compare the timestamp, right, of each of these objects, and in that you would convert everything into an epoch, and that gives you the number of milliseconds transpired. That's probably the easiest thing to compare how old, if you're trying to kind of compare two objects, try to determine if they have the same date value or not, is to convert this into those milliseconds. So these are getters and setters that allows you to fetch the time informations, metadata from a date object. Yep, so this one is a very short, I think you can probably finish this in like 15-20 minutes at home. Okay, all right, any questions about data object? There's that reading assignment right here. This math object is a library. The reason why we're introducing it is because it's pretty common. You would invoke the math object by writing out its math object name and its dot operator and the name of the methods. Okay, so math pi corresponds to 3.14125. So this is the value that you get. I don't think you need to import this math library. You can use it. I think most of the native JavaScript just-in-time browser, they already have this baked in. And then you can specify the natural log. This is a natural log 2, which is this. I think this is natural log right here. All right, so this is not a math class, but you can see if you ever want to make use of the existing sort of functionality like square root of something, you can invoke its square root library on math. Okay, this is not something that you need to compute. You can just make use of it as a utility. Math object also has a couple of pretty important stuff that you need to know. This one is really common, this power, right? This is like in some programming languages, they have it as a hat. So you literally write something like 2 to the power of 4, something like this. Okay, but in this you would say power to 4. Okay, so this is kind of how you would do it in Java. Sorry, I should have used something else, some other colors. Make sense? All right, the other thing is about floor and ceiling. So this floor and ceiling corresponds to this and this respectively. So let's say if you have 4.1, right? Sometimes you want to get to the the upper nearest number. If you do a ceiling on that, on this number, you get what? You get 5, okay? But if you're to get the floor of this number, this gives you 4, the lowest closest integer. So this is the difference between floor and ceiling. Okay, ceiling and floor. Make sense? And then you have cosine, you have sine, absolute value, minimum, maximum, the rounding of, rounding takes any decimal that's greater than 5. That'll give you into the nearest, right? So that's the difference between round, floor, and ceiling. Anyway, you don't have to memorize this, but I noticed that some of the math informations, you could leverage these methods to get what you need. All right, any questions about this? Yeah, I hope this is straightforward enough. Yeah, I'm gonna just let you go back and please go through these reading assignment. Okay. I think if you can get through maybe a quarter of these, that should be sufficient. All right, so next up is exceptions and try catch. This is a slightly more advanced. A lot of times we go through these in intermediate programming languages where we catch errors. So errors are things that happens at runtime, and these errors are typically associated with when, let's say, your program encounters an issue when some value is not supposed to be there. Let's say, for example, if you have an array of 3 elements in there, and then you do, let's say this is ARR, you say ARR, 10 equals 1. But this one only has 0, 1, and 2, right? So there's only 3 values in there. You can go up to 3, but not 10. Something may happen. In that case, you want to have a try catch. And yeah, we'll give some examples here. So try catch is a way of capturing errors. So let's say if you have a piece of code, right? And this is your code, okay? From top to bottom. And as your just-in-time JS interpreter, okay? Start to interpret your JS code right here, right? Just top to bottom. And it sees that there's an issue right here. But there's also a try and catch. There's actually try and there's catch. What happens is your flow of control is going to stop right here. And it'll try to catch what this is. Obviously, you have to write your own catch to capture that error, and then you can handle that error any way you like, right? Maybe outputting some user-friendly messages that says, hey, you just encountered this issue, please try again, right? Something like that. So this is a way of capturing errors at runtime. You don't do try and error exception handling at compile time, right? There's no such thing as a compile time in JavaScript. You'll do this at runtime. So let me see if I can get you some examples. If you scroll down a little bit, yeah, you'll see this throw. This throw statement says throw a user-defined exceptions. This means this tells your execution to basically stop there and just follow where the exception is at. Okay, I know this might sound a little abstract, but the whole try catch, it's literally this. In this try catch, there's no throw, right? So throw, by the way, this is throw, not throws. Okay, there's a difference between throw and throws. Sorry, THROWS. The former is associated with a user-defined exception, custom exception. Throws means you want your entire method to, and the method associated with it to bubble up, right? If you recall from other programming language, when you call a function, that entire function or method finishes and the entire flow of control goes back, right, to the caller. So throws, which is a plural, relay that exceptions to the invoker. Okay, I don't think there's a throws examples here. There's, if anything, you only see throw in this chapter. That's fine. Okay, so we'll focus on throw, but yeah, we'll see example of throws downstairs. But I just wanted to see there's actually a difference, and there's such thing here. You see a lot in Java. Okay. Any questions so far?
Yeah, I have a question about exception. Is it always going to say exception in
No.
catch, or
No,
and what is that defined by?
Yeah, so that exception is, yeah, that's a very good question. Let me see if there's an example of that. So there's different types of exceptions. There's exception associated with numeric exception, meaning when you have a number that is not really a number and you try to do something with that number or that fake number, that generates exceptions. There's general exceptions, or there's an input output exception. So there's various different type. When you just put exceptions here, that means you're trying to catch general exceptions. So I believe in JavaScript, you don't really specify what type of exceptions it is. So JavaScript has a pretty lightweight sort of in terms of it's handling the error. It doesn't really differentiate whether this is exception type 1, 2, 3, 4, but in a more full-blown Java language, you'll see this differentiation. Even in C++, the granularities is there, but in JavaScript you don't. So you just get to see this exceptions. Typically, this exception is a type, and then you will have a variable associated with it. That way, when this variable is of that type is getting thrown at the catch level, you can output what's inside that exception object value, right? Because a lot of times these exception will catch, the execution and say, hey, you gotta stop right here and do something. You would want to take the opportunity as a developer to also output the value of that exceptions. So there's actually a lot more involved in this, but JavaScript doesn't really give you that. It just says exceptions here. Yeah, any questions about anything else that we've talked about so far? We're not done, by the way. This is just quick overview of this try and catch. But yeah, what I want to do is to go through this with you at the same time. Okay, so let's do this again. The very first thing is we have, let's see, we have find sum. So this is a summation method that takes in this entire number from index, starting index and end index. So it sounds very straightforward, meaning if you have an array of numbers, you want to find the summation of these elements together from index 0 to index 2, from index 3 to index 4. All right, so the very first thing is you console log, find sum, you get 6, right? So this is all good. This is valid. Let's look at the very next one, which is not valid. And this is going to run into an issue because your array only has what? 4 elements in there, right? The very last element is index 3. So there is no index 4, right? So let's look at what happens. It equals 3, 4. It goes into if and else. And this entire if and else has throw. So this is a user defined, and index is too large. This thing actually doesn't get printed. This is just a watermark that says, hey, at this moment in time, at this location, this n index is too large. But there is no console.log, so nothing gets printed out. But this entire throw stops the whole execution right there and says, hey, at this moment, you're going to handle user-defined exceptions here, right? So this entire throw is associated with a catch, but there's no catch here. So let's see what happens then, okay? From this throw, the execution goes back, right, to the caller, right? Who's the caller? The caller is this, right? So that animation that shows the caller above, this is incorrect. I believe that red has to be here because this entire exception is thrown by this clause right here, the second clause. Make sense? Yeah, so your execution is going to go back and there's nothing there. And if there's nothing catching this exception at that moment, your JavaScript is going to output this error called uncaught, right? And then your end index is too large. This entire thing gets printed. So you can think of it as a function that produces whatever the effect of throw, which is uncaught, and then whatever the watermark is left by the user. So that's kind of what happens there. Now let's look at the other snippet where this thing is probably thrown with a try and catch. Okay, let's take a look at it again. Three, 4, and then it's gonna go into the throw. this entire throw is going to be caught by the exception, and this entire exception is going to be printed, okay? And that exception is n index is too large. This entire thing. Number 5, this is after everything's done, right? Because there's nothing after cache. After this entire cache, you print it out, you're done. All right, there's actually a whole lot of chapters on these. Like you're gonna have to go through this. I'd say maybe a good 1 hour. I think you'll get it. Maybe 2 hours. Yeah, this is a very big topic that is very crucial and fundamental to the well-being of your code. Because a lot of times when you don't do try and catch, your code is gonna strewn with a whole bunch of bullet holes, and it's very brittle. It becomes really brittle at runtime. It could break anytime. You don't have anything caught. You have no idea why the program all of a sudden, stops, right? So you got to do this. All right, I think, yeah, this is usually I spend about like half a lectures on this try and catch, but I don't think we're gonna have enough time, seeing that it's already 8 o'clock. Let me see. Yeah, so what I wanted to talk about is the finally. This finally is almost, you can think of as if and else, and all of a sudden you have that at the end, this thing called else that capture the remaining portion of your logic, right? And as in switch case, where you have switch case 1, case 2, case 3, and then the very last one is going to be default. So this finally is kind of like default, where if none of the exception is caught, it will still be caught in a finally block. So this entire finally is, let me see, I just kept passing it. Yeah, it looks something like this, right? So you have catch 1 and maybe another catch, and then catch. By the way, these catch could be chained, okay? So you can have this catch exception, but in Java, there's one exceptions there, and you don't typically handle multiple of them. You don't catch multiple of them, and you can, for all intents and purposes, you can write this exception as ERR or errors or anything you like. So JavaScript is pretty loose, and then you can use log, console.log or console.errors or something to print it out with some details. Again, this is kind of beyond the scope of what you need to do. Finally, is even though if the catch is not caught or triggered, finally it will still be called. So this is kind of like the last resort. It's like casting your net wide enough so that even if some of the fish didn't get through the first layer of your catch, it will eventually fall into the outer part of your cast, your net. So this is kind of like what finally is. And this is really where you can close the loop on everything else, right? You want to assume that maybe none of the catches before you had a chance of catching these errors, so you can do some finally stuff at the very end. Okay, so I think there's some examples of this that talks about the finally, so you can try to go through these yourself. Yeah, this thing is pretty dense, so there's maybe 4 or 5 different examples that goes through these. So make sure you understand why this is the case. Now, if there's anything that you don't understand, just ping me on Slack, okay? And I'll try my very best to see if I can just walk you through something there. Yeah, so this error object is also used in the sense of, let me see. Yeah, for you to print this out, the throw statement can throw any exception to a commonly known as error object. So this error object will basically capture all of the metadata that you have in there and create an error. And you can cache the hold on a second. Yeah, you can catch the errors and try to print it out, or try to initialize it with your own sort of error messaging that is custom to the type of logic or business logic that is throwing an error, to store them in an ERR object. And this ERR could be named anything else. You can call it A, B, and C, okay? It doesn't have to be ERR. But by convention, we use the ERR to capture a lot of these messages. And a lot of time these errors comes with the error's name, errors messages. So you can store in informations like this. It's like an information object. I was trying to look for this. So make sure you go through maybe half of it, like up until, yeah, don't even worry about custom error type. I think this gets into very advanced level stuff. I think this will be more common and useful when you get into client server web programming. Okay, doing some some basic JavaScript to interact with your HTML, CSS. You don't really necessarily get into this level of details, to be honest. So yeah, I mean, I would dial down the amount of complexity in terms of studying this chapter, okay? And maybe go through some of the high level, maybe up until this, and try to make use of the code and illustrations as much as you can. See if you can get past the PAs that way. All right, let's go back quickly to look at what we have left. So we covered basically the entirety of chapter 6 in the past 3 weeks, okay, 2.5 weeks. Right now, let's move into JavaScript in the browser. Oh, notice that in the JavaScript fundamentals, there's a whole lot of labs. So you're going to have them this week. Since we didn't have them last week, your responsibility would be these labs. I think there's like 4 or 5 of them. Hold on, give me a second. Yeah, there's 4 labs you have to be responsible for. 5, 6, 7, 8. They are from this, okay, right there. And that should complete the JavaScript fundamentals. And then you have the regular homework plus the quiz that's about these topics. Okay, so right now we have using JavaScript, HTML, document, object model, modification. I think we can go through all 3 of these. Let's see if we have time for it. And they are in chapter 7. Okay, let's start with that. So yeah, many of you came from my HTML class, and in HTML there's some such thing called document object model. This DOM, D-O-M, is a data structure that stores basically all the bells and whistles of a HTML document. And the bells and whistles includes HTML elements and its attributes, and a whole bunch of the sequences that involves. It's basically a tree. Okay, so DOM is a tree. So maybe some of you had data structures before. A tree is something that looks like this. It's a binary tree. Okay, binary tree. Sorry, I don't write well. And let's go back. Okay. Yeah, the joke, the running jokes that I have is I've been a software developer for so long. I talk to the computer, so my English sucks, and I don't write because I type, so my writing sucks. So nothing is good. But my coding skill is pretty good. My ability to produce software application is good. My ability to coach people and mentor people on how to be good at doing software engineering is good, right? All right, so please forgive my writing here. This is a binary tree, and it's what we call DOM, right? Document object model. It starts with roots, and this is the entry point of your HTML. So you can put a lot of documents in there, and this is what is behind your browser, okay? And then inside this entire browser, there's a whole lot of stuff associated with it. One of them is JavaScript, and the other one is CSS, right? CSS is more about styling, and JavaScript is more about your script, your interactivities. So you use the script tag to enable JavaScript in HTML. You can also make use of the browser APIs. These are JavaScript browser API. Okay. Whenever you see something like documents or windows, by the way, this is a differentiation. Inside your browser, there is a just-in-time JavaScript compile interpreter. And on your Chrome browser, that interpreter is called V8. Okay, that's the Google thing. And inside each browser, there is sufficient amount of JavaScript libraries inside of it that you can make use of. And these JavaScript could be used to operate your DOM model, right? So you can think of, there's a lot of utility functions that is part and parcel of your DOM object in the browser. And these JavaScript libraries are very proprietary, but a lot of browsers, they're trying to consolidate and unify them. And still, there's browser-specific JavaScript that works in one browser that you can use to manipulate DOM. They are very different than some of the other browsers' DOM JavaScript libraries. Does it make sense? So when that happens, you have this vast amount of idiosyncrasies associated with one browser versus the other. So literally, it is impossible to write one JavaScript that works on multiple browsers. So that has been a pain point for web development for the longest time. This is the reason why there is an advent of jQuery, some of these cross-browser JavaScript bridge that marries different types of JavaScript together by saying, hey, stop using these document write, use my jQuery, because my jQuery can bridge what you want onto various different browsers and make sure your logic is interoperable. Okay, so the reason why I spend so much time talking about this is this browser JavaScript. Okay, this is, by the way, this is browser. This browser JavaScript is not your native JavaScript, okay? These browsers JavaScript is a souped up version of JavaScript that has very specific DOM API associated with it, such that you can manipulate these DOM, like removing an element, inserting an elements, or you can do some creation of a menu or something like that through these JavaScript that browser understands. They are very different than the vanilla and generic JavaScript that we've been talking about, okay, as of late. Make sense? So that's why you see these JavaScript code, and yeah, but because browsers are getting more and more unified, right? These days, like after 20 years of web development, there's got to be something that everyone agrees to. And that's the reason why you see these consolidation and unification of JavaScript with HTML these days. So basically, you can write one and work on maybe 90% of the browsers. That's considered pretty good. All right. Any questions so far? Let me see. 809. I think, yeah, maybe let's do another 20 minutes, and then after that, I'm gonna be so beat, after after teaching a couple of classes today. How's everybody? Good? All right. So there is a document, right? Oh, this is not a PA. Yeah, so this is one example of JavaScript that you can use on a browser level to read the HTML and JavaScript below, render a web page to run JavaScript code. And if you look at this code, what's so different about this? Yeah, there's some JavaScripts in it, but everything is inside this script tag. Okay, so you can write what we just learned, right, today or last week, creating an array of 3 string objects, and you can use math floor. Remember what math floor? Yeah, dot floor means getting to the the floor object, right? The lower.
The lowest integer.
Yep. And then I think we missed math.random. So this is a pseudo number random number generator. And this pseudo number generator give you something that is not truly random, but it's quite random if you just run it once or twice. But if you run it, 3 million, 4 million times, you can probably see some repeat patterns of these numbers coming out. But math.random basically gives you some random number and times whatever this algorithm is doing. And you can try to document write this, okay? With I believe this ln gives you a line space, okay? Line break. So that's it. You can write your HTML strictly with, in a sense that this is a string you try to concatenate this with another string plus another string to end this. So this entire thing basically says, just write this entire payload into the DOM model, okay? So that entire web page starts with what's called Windows, and there is this, sorry, what am I doing? Going back. Yeah, so this entire, oh, yeah, so this entire web page, this document, okay, and there's window outside the document. But this document is that whole tree we're talking about here. Window is kind of outside of that. Make sense? So this is kind of the window, and this entire thing inside of it is document. Okay, so when you do document.write, ln, this is saying, hey, I'm gonna write this entire HTML payload into it, and then, please insert it into the DOM model, right? So this is a very useful feature that allows the developer to directly ingest a marked up HTML. Okay, so HTML has marks, right? These markings like p tags, right? Div tag, right? These are marks, markup. So you would, insert this markup directly into the DOM model through document.write or document.write ln. Write line. Questions? All right, sounds good. Let's clear this. Let's move on. Yeah, please practice this, okay? You can render the web page anytime you want. Just keep going. So there's a Windows object that we talked about earlier. So the document object is a nested object inside Windows. So we talked about this. You can use Windows location to define the specific, XYZ of, oh wait, hold on a second. Yeah, no, Windows location is not XYZ, sorry. It's the URL. So literally, if you say Windows.location is, associated with 127.0.0.1, that's localhost, it will point the entire Windows URL to point to that host to get the contents back. Does it make sense? So it's kind of like the window, it's a client-server communication thing. So it's a little bit about, how you fetch information. You will only use that Windows location in that context. All right, so then there's an XYZ thing. This is the format. There's Windows.alert. This is almost similar to console.log or console.error. That gives you the error of a window. You don't write this a lot, right? If you do this, it becomes really annoying because every time you load that page that has this thing will pop up and says hello, and it's just annoying. But you will use these as a debugging feature, I think, to oh, not this one, the Windows confirm and alert to build something, but at production time you want to remove them. There's Windows.open that opens a new browser windows, so you can use JavaScript to trigger a new browser window when user clicks on the button, for example. So that's a very nifty document API or browser APIs. Okay, this dot opens. All right, and what else? Yes, this is more like the console.log. So inside this, if you haven't already, if you use Chrome, okay, if you use Windows browser, there's something called inspect element, like Internet Explorer. I think that one is defunct, but yeah, you'll see this inspect element or inspect, and right now, this my developer mode is set in dark mode, so it looks maybe a little different than yours. But there's this console tab where you can get to. There's also sources, network. Yeah, there's a lot of stuff to it. So basically what this using the console means is when you write JavaScript, you can go back to the console and see the error pumping out. So believe it or not, there's a lot of these errors. Sometimes developers don't look at them. They just let it absorb, and nobody goes into the console, right? As a user, like when you shop on Amazon.com, eBay.com, you don't do inspect element and see, hey, I think eBay is throwing me these errors, so that's not good, right? Nobody does that, right? Unless you're super bored. But these are things that, as a developer, gives you valuable insight to debug and make your code better. Okay. And yeah, as you do this, you'll notice that like console error, I said earlier, worm and directory. Yeah, these are very important basic like debugging tools and facilities that you want to know when you write JavaScript. Okay, so yeah, I think this is a very good overview of what you can do with just your browser to write something really simple in JavaScript. Questions? Yep, you can also write. Yeah, I think I went over this in a prior class. Is you can use a script tag to load instead of doing an inline loading, right? Which is writing a JavaScript script itself inside your entire HTML. The other way is to externally import a JavaScript file using source. So this source points to the fully qualified URL. So if you don't have a URL and you know that file is located, for example, at the same location or maybe in the subdirectory of where your current HTML is that has this line of code, then you can use the relative path and not absolute path. But if this external file is from an remote server, then you want to have the IP address and whatnot, so basically the whole URL. Okay, so that was that. Okay, so there's a lot of PAs. You're gonna have to go through these on your own. But let me pause for a second. Any questions so far? I'm just giving you this super high level overview of it. Please study up on these. These are not optional. Okay, please go through them and at least 50% of them before you move on. But yeah, otherwise, yeah, just by going through these PAs, not going to connote to much learning, if any at all. Okay. Yeah, so we talked about DOM objects. So this is where how HTML gets stored, right? You have roots and then you have head, body. So I think the best way to go about it is to start with this animations here. On the very top, the root object is what's called HTML. This starts with everything. So if you look at this entire HTML, and there's a lot of super nested stuff inside of it, and everything is explained in the form of a tree as a data structure. So second one is what's called title. This is the heading section of it. You don't see head, so some of those are optional, but if you don't, they are still literally part of your head portion of your HTML. Next one is, this is Moby Dick. So this Moby Dick is the value associated with this particular node. So every node has a corresponding leaf node that represent the value. Sweet. That's how I looked at it. So next up is you have the entire body. This whole body is separated in parallel to what you have for the head. So you can think of these as a binary tree that such that each node has two branches, right? That goes left and right. So body has a p tag, and actually body has two p tags. There's two in parallels. Let's move on to the next p. Oh, this is a class. So this particular p is associated with this pink class name, right? This class name is where you can apply potential CSS to it, okay, programmatically, or you can do this inline. So I think I talked about this in a prior class. So next one up is what you have the whole value as well as the next p tags. So this other next p tag is literally a sibling node of the other p on the same level. So if you look at this entire tree, sorry, this is a little bit of data structure we're talking about. This is a different class, but this is level 1, level 0, and this is level 1, and this one is level 2. So this tree has a whole bunch of what? HTML attributes, right? Or elements. It also has, actually this big is not an element, but you have sometimes CSS strewn inside this, as a relative, as something that is related to it, and you can see the relations here, plus the actual values associated with each of these node. So you can kind of see that this value sort of terminates. So they become what's called the leaf node. Yeah, when you have a node that goes on, they're called node. And then any node that terminates with nothing after that is what we call leaf. Okay, leaf. So this is tree DS, data structure. Okay, so that's how you would represent the entire DOM. Any questions so far? All right, let's move on. Yep, this is another giant version of your DOM tree. And the DOM windows, yeah, this is a good PA for you to go through. All right, so this one is, yeah, this is usually something I'll spend like half a lecture on this, but I can only go through this on a survey level for you to look at, given the scope. Yeah, it turns out that this document object has a lot of methods associated with it. Get element by ID, get elements by tag name, by class names. So if you look at something, let's say an element diff, right, that has a class name associated with it. Sometimes it's got ID associated with it, like equal sign. This is X, this is Y, so on and so forth. You can programmatically fetch, this particular div by way of get element by ID. So this div is what we call HTML elements, right? So get elements means get this entire div by this class name, get this entire div by this ID name, hence get elements by ID, hence get elements by class name. Does it make sense? So you will have this strewn all over the places. Of course, your class could be something. Class could have duplicate values, meaning you can have multiple div with the same class name. However, ID must be unique. Okay, ID must be unique. And Professor, what happens if the ID is not unique? Well, you're going to see errors. So you got to be really careful with how you define the ID, and usually there's a convention for it. If this is a div, you can write them as a div underscore ID, but you have to append something unique to what this elements is, to avoid having multiple elements with the same IDs. Anyway, so these are sort of the data fetcher, right? Once you get the entire element, you basically get that entire subtree. This entire element could be a portion of a subtree that has a lot of information in it. And once you get this, what can you do with it? You can do a lot of stuff with it, right? You can change that entire div's background color, its foreground color. You can make some animation that goes through that entire div. You can actually split that whole div into I don't know, I'm just making things up, but you can do a lot of stuff, interactions with it. This is the reason why we have these document dot methods. You can also use query selector all or selector. So this is the CSS, facilities that you can use JavaScript to program. So this is a very powerful stuff. Okay, this is where rubber meets the road, where JavaScript meets HTML, where JavaScript meets CSS. Okay, all right. I don't know if you guys have any questions, then probably do, but I just don't having a lot of time to go through these. But questions so far? Any high-level question? How's that? All right. So you will see LAI. So if you're not familiar with CSS and it's been a little while since you took it, go back and see what this is. Okay. For those of you who just had CSS, HTML, you should know what this is. This is a very important feature that gets you to the specific portion of that DOM tree to effectuate changes to it, right? So that's that. And searching by DOM, I think we can probably go through this. Yes, there are 3 frames. The very first one is insertion of your DOM.js. So that's great. This DOM.js is going to have these 2 methods. So let's take a look at what the next one is going to be. Right. The very first one says get element by ID. So that ID is called early_languages. And it just happens to be this P tag right here, P elements. So that whole element is stored inside this parent, right? Value. So far, so good. The next one up is document.querySelector li. And this actually gives you all of the li children in this. So this is a whole subtree that has everything under, OL. On OL stands for what? Order
list.
Order list.
Organized list.
Yeah.
Or
Yeah, order list. So you have 4 LIs here. And those 4 LIs becomes an array stored inside this list items. Make sense? Yes. So you can use JavaScript to do a lot of stuff with it. You can group them, you can delete them, you can fetch them and do something with the data sitting inside each of them. So there's a lot of things you can do. After you fetch them, you can write a for loop to do a for in, right? Remember for in we just talked about, or for of. You can do that to get each individual items out, like, and then even parse the href associated with it. Href is the URL. So yeah, you can write literally the web crawler, right, using this. Okay. Yeah, this is all very basic HTML, CSS stuff, making use of the query selector and query selector all. Give it a tag name, so there's a tag name. We don't use tag name a lot, but yeah, you should know what it is by ID and class. All right. So the very next one is modification with DOM nodes attributes. This is where you can dynamically change stuff. I think it's probably better to just go through this and see how it goes. This is a little more advanced, by the way. So this is the entire page that shows this. Very vanilla, right? Nothing. Now, what I want to do is, I want to run I want to run my JavaScript in orange here. And this is assuming that JavaScript is already loaded via some sort of script tag, right? Somewhere above the body right here. Usually you want to load your JavaScript at the very top, at the head section of your HTML. So this is saying, hey, I'm going to dynamically modify this. Let's do this again. My source and alternate. So this alternate or alternative is when the source is not available, then you would just have it print this. This is for web accessibilities. Someone with disability, for example, they can mouse over using their screen reader to read the alt tag. It says mountain photo. If you have nothing there, then and if this entire thing doesn't work, then no one knows what's going on, right? At least someone with disability thing. So there's some disability feature associated with this. And this also gives user a better user experiences when the source does not load. And people with good eyesight, they can see multiple windows, right? This is one of the biggest accessibility myths in websites when they're created and they're not friendly for, someone with a DSPS. So yeah, you can use this to dynamically change your unpopulated data inside this particular element. You can also use the query selector to say, hey, for this P, I want to apply a style to it. And so this is how you would programmatically change the style of a particular part of the tree. Okay, that tree could be that whole paragraph right there in this case, or it can be the entire image tag, right, associated with this. So this is a very simple PA. Again, you got to do this and you see this orange mark that says check. That means you're done there. Otherwise, you're going to have missing points. All right, let me see. Yeah, this one is a very heavy with labs. So please go through them. That talks about basically everything we talked about. Then if you want to get a sense of what this DOM is really about, yeah, this is a pretty thorough stuff. I would say maybe the top 10% of what's the most important would be important for you to know. Otherwise, everything else will be optional.